Hello everyone, I am Harsh Khattar, working as Assistant Professor in Department of Computer Science and Engineering at ABES Engineering College, Ghaziabad. Welcome to the lecture series of Computer Networks. Today, we will discuss about the delay analysis and network design. In last class, we discussed about the network devices and at which layer which device is used, how the network is organized in the form of topologies. We discussed about the various topologies. And today our focus is more on the network delays, how many types of delays are there in a network. When we talk about the central network, what is backbone network and the LAN basic network design parameters. So, let us have a look to the delay. In lecture number 3, we discussed about the performance parameters of a network. Today, we are more focusing on the delay analysis. So, before the delay analysis, it is required to understand how many types of delays are there and what type of delay is there on which point in a network. In the figure, you can see there are two nodes, the sender and receiver, and whenever we want to send a particular message, so these delays are involved. If I talk about the basic functionality, so very first thing is to prepare a message. This is a message which sender wants to send it to the receiver point. And how to prepare this message? Suppose I want to send a packet through a WhatsApp. Suppose I want to send a hello message. So, how this hello message is being created to send in a particular communication channel to be received at a receiver end. So, this is known as the preparation of a particular message which is ready to send to a particular network. So, this is step number 1. Second step is the transmission over the communication network. Means my packet is ready, that hello message is ready, which is wrapped at so many times by the header and the tailor by the OSI model, and now it is ready to transmit. Now, when we are talking about ready to transmit, what exactly it means, that this is the communication channel. Now, this packet, this message is converted to the packet, and this packet or signal is on this transmission link. So, from this point to this point, we have a transmission link. So, this is basically the transmission over the communication network. This is the second step. Third step is basically how a receiver is receiving this particular message at its own computer or system. Then once a particular message is received here, then the next step is to use by the specific application. So, obviously, when we are sending a data, it will be mapped with a particular application and port number. So, this message receiving is one task and message processing is another task. Suppose I have my mobile or my laptop has received one notification, but how this notification is converted or processed by the application to be in a readable format. So, these are the 4 steps which are important to understand before the delay. And now, on behalf of these 4 steps, 4 type of delay are there in the network. Okay? So, the steps are very simple. Step number 1, just sender is creating a message. So, now make it prepare for the sending. Then the second one, the transmission one, where we are going to transmit it. Third one is just received at the receiver end, and the fourth step is the processing by the particular application. So, these are the 4 steps. Now, if I relate these steps with the delay, so let us have a look to this figure, that we have basically these type of delays. You can see the numbers mentioned on the figure, that very first delay is known as the transmission delay. When we are preparing our packet, so that is the transmission delay, that yes, I have sent the hello, I ticked on the hello, or I am shooting a mail, but this mail is now converted to the appropriate signal to be sent, or my hello message on WhatsApp is being prepared by my system to be sent over the network. So, this is known as the transmission delay. Once the signal is ready, once the bits are defined, might be it is analog signal or digital signal. Now, this signal is going to be travel on a communication path. So, this is my communication path, that is why it is mentioned here. This is my second, which is known as the propagation delay. Propagation delay means it depends on the basic the transmission speed of a particular. Suppose I have given an example of twisted pair in the last class. So, twisted pair has the more error rate and the range is less. So, the speed is also less in this case. Fiber optics, it has more speed. So, in this case we can say the delay, propagation delay is with respect to the transmission speed of the particular link and what type of data we are sending. So, here this is my propagation delay, the second important delay. Now, I am sending a packet to the receiver end. Might be receiver is receiving the packet from multiple nodes. This is sender, this is say B node, this is say C node, this is say D node. Now, B, C, D, all three nodes are also sending the packets to the receiver end. Now, receiver is unable to receive these packets in the bulk. So, here there may be chances that some of the packets are going to wait for a time until the receiver is taking the packets one by one. So, here there is a queue to be maintained where the first packet is from the sender side, then node B, then node C, then node D. Once the sender packet is received at the receiver end, then the processing will start. After this, node B's packet is coming to the receiver end. After this, node C's packet or the particular signal is received, then after this the node D and so on. So, this is a way how the queuing delay works. So, yes, by default we assume that the queuing delay is 0, if we are not talking about the so much nodes who are sending the data, but yes, this is there. Take an example of the big servers. Suppose your result is out and you all are sending the request to the server to find your result, okay, or few days back there is a result of 12th class or 10th class. So, in this case so many clients are sending their request. So, in this case there may be a queuing delay at the server end, that they are maintaining a particular queue. So, this is the example of queuing delay. Once these things are done, we have another category, which is the category number 4. This is a special category which depends on the receiver end only. Receiver end means that how much time it will take to process a input data. So, the input data which is coming to the node, the particular message or the packet which is present here. So, yes, it is coming there. So, how much time it will take to process a particular thing. So, that is basically known as the processing delay. Okay. So, this is the scenario based example which I have discussed here to explain 4 types of delay. Let us have a look to the theoretical part, that which delay denotes which particular definition. So, these are the 4 types of delay. Transmission delay is one thing which is known as the time taken to put a data packet on transmission link. So, very first thing is to prepare a packet. So, once the data is prepared, only then we can deploy it on the transmission link. So, this is known as the transmission delay. Another one, the time taken for one bit to travel from sender to receiver end of the link, means I have this node, this is sender, this is receiver. So, on this link, if my packet is there and I am talking about the first bit which is present here. So, this first bit is moving from sender side to receiver side. So, how much time this particular bit is taking to receive at the receiver end from sender. So, suppose this is 0.1 second. Okay. So, this will be treated as a propagation delay. Next important thing is the queuing delay. As I said, might be there are so many senders who are sending the data at a particular receiver end. So, in this case, there may be chances that the receiver is unable to receive the packets in the bulk. So, here a buffer is required to line up all the incoming packets. So, in this case, this type of process or this type of functionality takes some time to organize these packets. So, here the time spent by the data packet waiting in the queue before it is taken for execution by the receiver node, that is known as the queuing delay. Okay. Next, after this, when the packet is now received, then this is another category, the last one, which is known as the time taken by the processor to process it. What it means? Means how much time a particular processor is taking to process it, because when we talk about the processing delay, it is up to the receiver end, and if this receiver end is processing a particular packet, so the speed of processing basically depends on the power of CPU. Okay. So, what is the power of CPU? Based on that, how many clock cycles are there, how many oscillations are there in a particular period of time. So, the processing is up to the power of the processor. So, these are some delays and the different parameters on which they are defined. If I talk about the example, or we can say what is a formula, how we can calculate these type of delays. Yes, we can also calculate these type of delays, and might be you will see 1 or 2 questions in the university exam in calculation of delay. Let us have a look to this. So, when we calculate the delays, so we have some formulas for each and every delay. Yes, the important ones are the transmission and propagation delay. The transmission delay is one where we are talking about the what is the length of the data packet. Okay. So, how many packets are there and what is the length of a particular data packet to be sent. So, by the bandwidth, how much bandwidth you have for this. So, this is basically the transmission delay. And when we are talking about the propagation delay, so it means what is the transmission speed of a particular link. So, based on the transmission speed, and we can say yes, distance between the sender and receiver. Suppose we are talking about a fiber optics, and yes, there is a laser beam who is traversing, and now the distance between the sender and receiver. So, based on the distance, we can say yes, this is the propagation delay. Like the sunlight is coming to the earth. So, how much time it is taking there. So, this is basically the propagation delay. Okay. And yes, the queuing delay is basically up to the network, that how many packets are coming to the particular receiver end and what is the capability of the receiver. So, basically it depends on the congestion on the network link, that how much busy a particular link is there. Similarly, the processing delay is up to the power of the processor at the receiver end, that how much clock cycles are required for a particular packet to process. So, these are some key factors which we can just go through that how we can compute the delay. Yes, there is one important question, if somebody is asking about that what is a total delay in a particular network. So, how you will do this? So, when we talk about the total delay in a particular network, so total delay is basically the summation of all. So, this can be the total delay of sending the one packet, or we can say the end to end time from sender to receiver, what is the exact time. So, that is basically the summation of all 4 types of delay. Generally, as I said, the processing delay and queuing delay, we can assume that yes, this is 0 because it is not up to the main constraint. So, we can say yes, transmission delay and propagation delay, but practically it is the combination of all 4: transmission delay, propagation delay, then we have queuing delay, and then the processing delay. And based on this, we can calculate the complete computed value of the delay from one node to another. Now, this is all about the delay. If I take an example, as I said, okay, we have a optical fiber. So, how we can calculate the transmission speed? So, might be there is a 2-mark question in the university exam, or there is a 2-mark question with the supporting 5 marks question, that how you can calculate the speed of the optical fiber. So, in this case, this is a very good example. If we say that the optical fiber signal travels with the speed 70% of the speed of the light. So, we know that the speed of light is basically this, and we are calculating it 70%. So, we can take the value 2.1 into 10 raised to the power 8 meter per second. This is the speed of the optical fiber if we are taking this as a communication link. So, this is the good example to understand what exactly is the transmission speed. Now, with the help of this, you can solve the multiple questions. There are so many questions which are given on the back exercise of these book. Till now, we discussed about the basic thing, that what exactly is the delay and how we can compute it. Now, the next important thing is the backbone network. What exactly backbone network is? Backbone network is one thing which we can say, yes, the whole network is dependent on this particular thing. So, how it is possible, and what are the key parameters where the network is depending on? So, as we have our backbones, in a similar manner we have a network backbone. So, generally the network backbone is defined through its infrastructure, which type of infrastructure we are using. Now, if we take an example of backbone, then we can say the central support is basically the infrastructural support, and which type of devices we are using. In general case, we have the big infrastructure, the stronger networks which are attached with the LAN. So, these LANs get connected to make a larger and bigger networks, and those LANs are then bifurcated into the another smaller networks, and these networks are propagating their messages through wired or wireless medium. So, if I talk about the central support or the backbone system, then we have this backbone network in the form of a great infrastructure for the better connectivity, for the stronger and reliable network. And yes, when we are talking about the multiple LANs, so here each and every LAN has a capability to scale up the network. So, we can scale up the network on behalf of our requirements. If there is a requirement, then in a particular LAN we can add the another switches and bridges, and on behalf of those switches we can extend our nodes. So, this is a good example that we can treat here, that yes, if right now I am just initializing my lab and initiating the basic functionality with 10 computers. So, I have make a structure, I have defined a particular server for the 1000 systems, but currently it is only carrying the 20 systems, and as the time passes or after 1 month I want to expand my network to the 100 computers. So, that particular LAN is now expanded and I am using a switch to this, and then those things are connected towards this, and further we can also use the bridge to split a larger network into the smaller one, and in the smaller LANs we can use the hub port. So, here this is the exact use of the network devices, how we are using this. And now, on the top, if we want to interact with the other networks or outside the particular organization, then the router is required. So, this is the way how we can use the network devices, the topology, and how the reliable and scalable network is established. So, this is the role of backbone network. Especially when we talk about the backbone network, there are various categories, like we have a distributed backbone network, there is a centralized backbone network. So, as we have discussed in the peer-to-peer and client server architecture, so similarly we can say, yes, this backbone support has two categories. One is the centralized. So, this centralized thing is basically helping us in managing things very easily. There is a common root where the everything is mentioned, but when we talk about the distributed environment, so in distributed thing there is some sort of hindrance that we can say, yes, the nodes are distributed and the data which they are sending are not going to the centralized server. So, there is not a central entity who is managing everything. So, it is again up to the usage which type of network you are using, and how we can say yes it is a centralized one, or how it is we can use the distributed one. It is up to the usage, but the example which I have given here for the backbone network is the centralized backbone network. In detail, if I talk about the main functionalities, how the LAN backbone network is designed. So, the major functionalities which are required are the aggregation. Aggregation means all the devices which we have added in a particular LAN are aggregated together to make a successful usage. So, this is very important thing to understand how we can organize our backbones, how we are organizing our LANs. Another important thing is the authentication. So, as we are dividing our backbone networks into the sub network, so in these cases the LAN are using the devices. As I said, the switch is powerfully maintained, that the filtering process is there. If a node is sending a data, then switch has a capability to filter out the packet. So, in this case we can say yes, the authentication is required. If a message is coming from a particular node, then just stop it or remove it from the network, and if it is coming from this network, broadcast it. So, this is the authentication mechanism which we can say yes, this is a good thing. Another one is the network switching. When we are designing a particular backbone network and we want to expand our network. So, in this case, in expansion there are so many devices which has their own limitations. Up to that particular number of nodes it will support, after that you need a larger device. So, in this case, if we are switching from one network to another, so this capability is very important to understand. If there is no such compatibility, then there is no use of the backbone network. Okay. So, in this case, to expand our network, to scale up our network, the network switching is very much required. So, these are few functionalities which are there in the LAN backbone network designing part. And the fourth one is basically the service invocation. Service invocation means if you want to add some other services, the set of rules, the protocols, then it should be easy to applicable. It is not like that I am using hub only in all the networks and now I am asking about the filtering. So, hub is unable to filter out the packet. So, in this case the switch is required. So, where to use which one and which type of service is required. So, in backbone network it is very much important to understand that which type of services you want. Based on the services you need to opt for the better devices and their network topology. So, that is why first we discussed about the network devices, then topology and then delay, and now we are talking about the backbone network. So, this is the basic organization how we can do these things. Another important concept is the gateway, because some of the devices do not allow you to apply the rules on the network. So, in this case we need to use gateways. As I discussed in the last class, that gateway is very important device where we can apply the rules, and yes, gateway helps us to sit on the border line of the network. Suppose this is my network which I am using. So, gateway will sit here and monitor all the inflow and the outflow of the network. So, in this case what type of data we are sending and what type of data we are receiving. So, gateway is the entity who is managing all the things. So, this is a very important point to understand, that what is the functionality of gateway and how we are using the gateway in expanding this. Okay. So, this is all about the backbone network. Rest we have to use the same reference model OSI, and practically we will use the TCP IP model for the data transfer and communication. We have the layers and we have some protocols which we can use. So, this is all about the backbone network. If I talk about the outcome of the lecture, if I sum up all the content. So, first we discussed about the delay. So, there may be a question in the university exam that which type of delay is there in a network. So, you need to explain or 4 types of delay. It is not there that I am saying assume queuing delay is 0 and you are not mentioning the queuing delay. No, it is assumed as 0, not exactly it is 0. Okay. So, when we are talking about the delay, so what exactly delay is, what are the types of delay, then you need to mention or 4 types of delay. Another important, why there is a delay in a network. So, when we are talking about the transfer of data, then if I am saying something, there is a speed of the light where you can see the screen, and there is a speed of the speech which I am sending. So, sound speed is there. So, still there is the delay in this. So, here we are talking about the sending of data over the network. So, it is also carrying the delay, and you can say yes, delay is not at one point, there are various types of delay, then you can discuss the different types of delays in this. Basically, when we talk about the networking, we can differentiate among the transmission delay and the propagation delay. This is a must question for the university. If you are preparing for the higher studies, then these questions are very important to understand. After that, there is a question, conceptual question, that what is the working of the backbone network and how you can define that which type of network is there and which type of network comes under the category of backbone network. And yes, might be there is a question to discuss about the network functionalities of LAN backbone. So, I have discussed about all these topics, and I hope you got all these answers. Now, there is a open ended question for you. If you are making your own network, then how you can minimize the delay? Yes, we have seen this point that delay should be there in the network, because there are 4 types of delay, and at any point, yes, you have a capability to minimize the delay. Might be we are talking about the processing delay. So, if you increase the power of your processor, so in this case, yes, the propagation that processing delay will be minimum. Yes, you are applying in a network that only one user can send the data. So, here the queuing delay is 0. You are using a very good type of communication link. So, this delay will be minimum, but we can't say that delay is 0. Okay. So, just talk about the basic things, that how you can minimize the delay in the network. So, this is very important thing to understand. This is a open ended question, and in my every lecture on the last you will see these type of questions, and it is good to practice and find out the answer of these type of questions. So, this is all about the delay. In next class, we will talk about the layer 1 physical layer and all types of communication wires which we have, and then we will start the working of the networks towards the upper layer. Thank you.